Right. Bluetooth is a wireless network. The cellular is also one of the wireless networks technology. Then fifth example, computer networks. Internet. Internet is a network of networks. It is a global network of interconnected computer networks that use the standard internet protocols used with the help of TCP or IP, transmission control protocol, internet protocol to communicate. It allows users to access a vast range of resources, including websites, email, and online applications. That is called the internet. So, internet is developed by old web network. Three scientists has been proposed. Sixth one is virtual private network. So, a virtual private network is a network that allows users to connect to a private network or a public network, such as the internet. Provides a secure and encrypted connection, making it suitable for remote workers or those access data. That is called a virtual private network. That is called a VPN. Then the seventh example of computer networks say cloud computing. Cloud computing is a form of distributed computing. Cloud computing is a internet-based technology. Cloud computing is a pay-and-use technology. Cloud computing allows users to access computing resources such as servers, data centers, storage, and applications over the internet. It allows businesses to scale up or scale down their computing resources as needed without the need for physical infrastructure. Means no need to purchase any physical servers, but the rental basis for getting the service from the service providers. So these are the 7 examples of computer networks. Then what are the major concepts of computer networks? So here are some key concepts of computer networks. The first one is a protocol. What is meant by protocol? How it is related to computer networks? A protocol is a set of rules and standards that govern the communication between devices in a network. Examples of network protocols include TCP/IP, Transmission Control Protocol, Internet Protocol, HTTP, Hypertext Transfer Protocol, and FTP, File Transfer Protocol. So these are the examples of a protocol. Protocol simply you can say rules and regulations of establishing bandwidth. So bandwidth is the next one more major concept of computer networks. Bandwidth refers to the maximum amount of data that can be transmitted over a network. Maybe local area network, wide area network, in a given time period. It is usually measured in bits per second. It is called bps. Then the third concept is latency. Latency refers to the delay between sending a request and receiving a response. It is affected by factors such as network congestion and processing time. So that is called the latency. Then the third concept is topology. Topology is nothing but refers to the way in which devices are connected in a network. Examples of network topologies include bus topology and a star topology, look like a star. Then ring topology and mesh topology. These are the 4 types of topologies. Then the fifth concept is routing. The router is a networking device that directs traffic between nodes. So router is nothing but the path section between source to destination. Uses routing tables to determine the best path for data to travel. It is called the router. Here we are using the key routing algorithms for a best path selection. Source to destination. Then the concept is switch. A switch is a networking device that connects devices within a local area network. It uses MAC addresses, direct traffic between devices. So that is called a switch. Then firewall. Firewall is the next concept in computer networks. Firewall is a security device that monitors and controls incoming and outgoing network traffic. So, firewall is a security device that monitors and controls incoming and outgoing network traffic. It can prevent unauthorized access to a network and protect against malware and other. So, suppose you are opening the market websites in an organization, immediately it can alert and block that. Like a pornography websites, it can block immediately. That is called a firewall security. Then DNS. Next concept is domain name system. Domain name system is a system that translates domain names to IP addresses. Like it converts into an internet and allows users to access websites use domain names rather than numerical address. No, my voice is audible.
Yes,
No?
sir, you are audible.
Okay. So then the 10th concept is cloud computing. Cloud computing refers to the delivery of computing services such as servers, storage, and applications over the internet. So cloud computing is a internet-based technology. Cloud computing is 5-4-3 formula. 5 characteristics, 4 infrastructure model, and 3 services. Then the examples of computer networks, nodes in a network include server or modems, computer networks, commonly held endpoint, users share resources and communicate. There are various types of computer networks. Like the first area network is called PAN, local area network or LAN, metropolitan area network is called MAN, wide area network that is called WAN, wireless local area network WLAN, storage area network SAN, virtual private network. So there are two basic types of local area networks and wide area networks. So local area network connects computers and the peripheral devices in a limited physical area, such as a business office, laboratory, college campus by means of links, wires, Ethernet cables, fiber optics, Wi-Fi that transmits data rapidly. Wide area networks is nothing but WANs connect computers, small networks to larger networks over greater geographic areas, including different continents. Metropolitan area network is nothing but it is a computer network that connects computers within a metropolitan area. So that is called map. Then which could be a single large city, multiple cities, and towns. You can call it as, or any given large area with multiple buildings. So that is called the map. Next, fifth concept is OSI, open source. You can call it as interconnection. Open source interconnection. Okay. So physical model is a conceptual model that must perform. You can call it as that describes how data is communicated over a network. That is called OSN. It consists of 7 layers, each of which represents a specific function with services that must be performed in order to transfer between two devices. The OSN model is a useful reference for network engineers and designers, as it helps to ensure that different network devices can communicate with each other using a common frame. That is called OSN. By breaking down network communication into discrete layers, the OSN model also helps to identify potential problems and improve network performance. So that is called OSN model. The 7 layers of the OSN model in order from bottom to top are physical layer. It deals with the physical transmission of data, including the hardware and physical media used to transmit signals. That is the physical layer. Data link layer provides a reliable means of transmitting data over a physical link, including error detection and correction. Next, network. Network layer is responsible for the routing of data across a network, including the selection of the most efficient path for data transmission. Next, fourth one is transport layer. It provides end-to-end data transport services, including segmentation, flow control, and error recovery. That is called the transport layer. Then fifth one is a session layer. It establishes and maintains communication session between devices or servers or data centers, including the attachment of multiple conversations between devices. Then presentation layer. It is responsible for the formatting and representation of data, including encryption and decryption. The fifth one is application layer. It provides the interface between the user and the network, including the authentication, example, email, file transfer, and other network services. So these are the 7 layers of OSN, open source. You see the diagrammatic representation of OSI model. First one is the physical model in physical structure, where we are using various coaxial cables, fiber cables, wires, hubs, repeaters. Then the data link layer, we are using frames, Ethernet, and the triple P switch, bridge, etc. Then the network layer, we are using packets like Internet protocol, MP, transport layer, we are using end-to-end connections. Here we are using transmission control protocol, user. So one is the physical oriented, the second one is a connection. It uses synchronous stress transfer. Okay. So in this OSA model, physically, it is responsible for transmitting and receiving data over transmission. Data link layer, which defines the format of data. Networking, it will decide which physical form the data will take. Transport layer, it is responsible for delivering messages between network. Session layer, it is responsible for establishing, maintaining, and terminating the sessions. Presentation layer, it is responsible for converting data into a standard format. Then application, it is a human-computer interaction layer where applications can access the network services. If you see diagrammatic representation with the description, like OSL model is a conceptual model created by the International Organization for Standardization with Peoples, diverse communication systems to communicate using standard protocols. See the physical layer, it topics lead over the this physical layer. Data link layer defines the network layer, it decides which is path the data will take. Transport layer transmits data using transmission protocols including TCP and session layer. It makes connections and it is responsible for controlling ports and sessions. Presentation layer, it ensures that data in a usable format and is where data encryption happens. Presentation layer. Okay, then application layer, human computer interaction layer, that is called HCI layer. Layer applications can access the network services. If you see the full description of OSA model, what is happening. So in physical layer, so connected with the connection and the unstructured topics, three growth. So application and examples of physical structure uses cables, hubs, etc. Data encoding, physical media attachment, transmission technique, based on physical media transmission, bits are here we are using inter-device protocols and the language layers, and you can call it as can be used in all on all layers, and the model is network model. Then data link layer. It provides error-free transfer of data frames from one node to another. So application or examples are frames. Envelopes contains MAC address, near field communication, NIC card, switch, NIC card, end-to-end. So here we are using the concepts like established here terminates the logical link, nodes, frame traffic control, frame sequencing, frame acknowledgement, frame delimiting, frame error checking, media access control. Here we are using central device protocols, switch bridge, wireless application protocol, or triple-PRs. So next, the network layer, it controls the operations of the subnet deciding which physical path the data is. The user's application examples are packets, letter contains IP address, internet protocol address, routing, subnet traffic control, frame fragmentation, logical physical address mapping, subnet usage accounting, etc. Packet and frame. So we are using protocols like routers, IP, IPX, IC. Then transport layer ensures the messages are delivered error-free in sequence and no losses or duplications. Applications are examples are TCP, transmission protocol, host-to-host local. Here we are using the concepts message segmentation, message acknowledgement, message traffic control, and session multiplexing. We are using packet filtering and protocols like TCP, UDP, SPX. Can be used on all the layers and the keyword host to host. Session layer allows session establishment between processes running on different stations, synchronous and send it reports, logical. Examples are application session establishment, maintenance and communication, session support, perform security, team recognition, logging, etc. Here we are using central device or protocols. Examples are logical ports, RPC, SQL, NFS, near field scheme, net, BIOS, names, etc. And presentation layer formats the data to be presented to the application layer. It will be viewed as the translator for the network. So application and example of syntax layer. Here we are using the encryption and decryption. So the concepts like character code translation, data conversion, data compression, data encryption, character set transmission, and protocols we are using APC. So ASCII, UPIC. Fifth, academic file format, academic format, PICT, etc. The application layer serves the window for users, the application processes to access the network services. Application or examples are end user program that opens what was sent or creates what is to be sent. Resource sharing, remote file access, remote printer access, directory services, network management, user applications. So that is about the open source interconnection. The first layer, physical layer. Physical layer is responsible for transmitting and recovering data over transmission. Data is treated as unstructured raw data stream. The actual physical connection between the devices on a network. Physical layer, transmission media, topologies, transmission via connectors, input segments, signal speed and voltage, signal encoding, transmission device, handshaking procedures, interfaces of data link. Next, functions of data link. We have a frame, addressing, synchronicity, flow control, error control, access control. These are the functions of data. So, data takes information layer, and this is about the functions of data. Network layer. So, this bit of the data link network, data link layer and network link from the transport. So the network layer controls the operation of the subnet, deciding which physical path the data should take, some network conditions, diameters, and other factors. Provides routing, subnet traffic control, fragmentation, classical physical address mapping, translates logical address or names into physical address. Subnet uses counting, and counting functions to keep track of fields, forward and backward net intermediate systems to produce belief information. Then fourth layer, transport layer. Transport layer of the OS model is responsible for delivering messages between networks. Transport layer accepts data from session layer, breaks into packets and delivers these packets to the network. Protocols like TCP, SPX, NetBIOS, ATP, and MWD. Network devices are the router, gateway, and the cable tester work on the transport. Transport layer services are end-to-end delivery, addressing, reliable delivery, flow control, multi-pass. Fifth layer, session layer. Session layer, it is responsible for establishing, maintaining, and terminating the session. Session ID is used to identify a session or interaction. Examples like RPC, remote procedure call, SQL structured query language, ASP, app and job session. The session layer is responsible for dialogue, growth, and synchronization. Sixth layer, presentation layer. It is responsible for converting to standard format. Examples like ASCII, EBCDIC, JPEG, MPs, bitmap, file, BMP, BD, etc. Following task format and presentation layer, encoding, decoding, encryption, decryption, compression. Then the last layer, how the application layer works. Like application layer used by network applications, sites based file transfer. We use protocol, then something HTTPS, hypertext transfer protocol, SMTP, simple mail transfer protocol. Then the types of computer networks and LAN, WLAN, and WAN, etc. What are advantages of computer networks? Like to share information and for testing, increase productivity and efficiency, cost effectiveness, storage efficiency and flexibility. So increase productivity and efficiency, cost effectiveness, storage efficiency, flexibility, and density. Then the sixth concept is tools in computer networks. So P, packet index network. It helps us to determine moves, latency, and trace route. Invaluable is by telling us what network traces are between 1 point and IP config or IP config. Internet protocol address of the host that we are working on. These are the utilizers to NS router locating the IP addresses associated with my name and checking to see the DNS domain name system resolution is what who is will give us detail about who is registered a particular domain. and often includes contact details for the register. NetStart. This utility is especially helpful on servers or hosts that run their own firewalls like SQL Server or Apache port communication. Subnet and IP calculator. IP calculators. IP scanners being able to scan an entire subnet networks to find IP addresses of devices. Speed test websites like speedtest.net help us to determine how much bandwidth we have in and out of our network. NSU. This is a great utility for two things: probing the IP addresses associated with the domain name, checking to see that DNS resolution is working for our host. Computer networks technologies like AI technology, machine learning, robotic process automation, edge computing, quantum computing, virtual reality, and augmented reality, blockchain, Internet of Things, 5G, fifth generation. So we can call it as Internet of Things, 5G, Internet of the systems. Then eighth one is the techniques of computer networks, coupled area network, wireless area network, wide area network, private network, virtual local area network, VLAN. A VLAN is a subnetwork that takes group of devices on a large network and creates the virtual LAN for those devices that will be separating them from the other devices. So ninth concept is computer network applications. Here are some common applications of computer networks like email. Email is a common application of computer networks that allows users to send and receive messages electronically over the network. File sharing is one more application. Video conferencing, that is one more application. Online gaming is an application. And the streaming services such as Netflix. Next, you can call it as online gaming, streaming services. Social media applications means one person is connected to another person. Remote access, e-commerce, voice over internet, cloud computing. So cloud computing platforms such as Amazon Web Services, Microsoft Azure, and Google Cloud allows businesses to access computing resources. Like examples are Amazon Web Services and Microsoft Azure, and the Google Cloud allows business to access computing resources such as server storage and applications. Then computer network challenges. What are the challenges? Like security is a challenge, bandwidth limitation is a challenge, interoperability means number of operations. Scalability means that scale is increasing automatically your data center. Network management, cost, downtime. Then the last concept is computer network algorithms. Computer network algorithms are a set of procedures, protocols, and rules that govern how data is transmitted, received, and processed over a computer network. Computer network algorithms play a vital role in managing and optimizing data transmission over computer networks. So computer network algorithms play a vital role in managing and optimizing data transmission over computer networks. Here are some of the commonly used computer networks algorithms. So like routing algorithms. Routing algorithms determine the best path for data to travel from the source to the destination. There are different types of routing algorithms, including static, dynamic routing, distance vector routing, and the link state. Congestion control algorithms that help manage network congestion when too much data is sent over the leading to slow data transmission and delays. Some commonly used congestion control algorithms include TCP, Vegas, TCP Reno, and TCP. Error control algorithms, security algorithms. Okay. So these are the different algorithms we are using. Flow control algorithms, network address translation, data quality of service algorithm. Okay. So the first program, good shortest path. See, write it, write a Python program, writing a full implementation of the open shortest path, OS. Now see here, command prompt. My screen is visible. Please tell me. I'm going to execute.
Yes, like his data.
So write a Python program, implementation of the open shortest algorithm. See, OSPF is nothing but open shortest path first routing algorithm in Python. Input network X as an X. Create network for this network. Calculate shortest path. Okay, now see the OSPF Python space. Shortest path, ABD, the path length is, you take any diagram to calculate. Next, second program. So this program, I'm going to share with you. So this code, please, in the WhatsApp, I have forwarded. You can execute this code. Please execute this. Okay, next, second program. Next, second protocol is writing a full implementation of the shortest path. First, root. When this program is over, implementation of the link state routing number is very important. So implementation of the link state routing algorithm in Python. So I'm going to execute LSR. Not add LSR. So implementation of the link state routing algorithm in Python. Okay, so components. So LS data on space. LS It is giving a link state routing. So there are 4 nodes in a network. First, it is executing C link state database for node. So there are various algorithms are there in computer networks. Algorithms. I'm going to share with you my PPT and try to execute a few more programs. I'm going to share the programs. Next. So with this one, I'm closing the theory session. Okay. Then interview questions. What practical session of the computer networks? Only I have two programs demonstration. What is a computer network? A computer network is a set of connected devices such as computers, servers, switches, and routers and printers that communicates with each other to exchange information and resources. What is the OSI model? The OSI model is nothing but open source interconnection. It is a 7-layer reference model for communication between computer systems. Short form is PD and TSP. What is the purpose of the TCP/IP model? Transmission control protocol, internet protocol. Transmission control protocol, internet protocol is a 4-layer communication model that serves as the foundation for the internet and the other computer. Short form is IL. So you can remember PD and TSP, that is OSI model. TCP/IP model, that is called the INTA. Okay. Internet layer, network layer, transport layer, or connection. What is a switch in computer networks? A switch is a device that connects multiple devices such as computers, servers, and printers together in a network and allows them to communicate with each other. What is a router in computer networks? A router is a device that connects multiple networks together and routes data packets between them. What is the difference between a switch and a router? A switch connects multiple devices in a single network, while a router connects multiple networks. That is called the switch and router. What is the difference between LAN and WAN? LAN is a network that is local area network that covers a small geographic area, such as a home, office, or building. A WAN is a wide area network in a network that covers a large geographic area, such as a city, country, or the world. What is the role of DNS in computer networks? Domain name system is a system that maps human readable domain names such as www.google.com to IP address such as 74.125.204.0. The role of DNS is to allow users to access websites and other internet resources using domain names instead of IP addresses. What is the purpose of IP addresses in computer networks? IP addresses called internet protocol addresses are unique numerical identifiers that are assigned to device in a network. What is a VPN in computer networks? A virtual private network is a private network that is created over a public network such as the internet. List out computer networks techniques. There are some common techniques like Ethernet, Wi-Fi, Bluetooth, NFC, near field communication, cellular networks, VPN, virtual private network, and domain DNS, domain name system. List out computer networks tools. There are some commonly used tools like ping, packet index network. Then there are some commonly used protocols like ping, traceroute, nmap, wireshark, Next, IP config, IF config, firewall, virtual private network, remote desktop, SNMP, simple network, SS protocol, simple network, SS protocol. So with this, I am closing the today's my theory session and practical session. So I am expecting from you your major project presentation and as well as your cyber security tool presentation.